It's easy to think token balances are stored on-chain, but they're actually not. On Ethereum and other EVM chains, there is no balance table. Instead, balances are reconstructed by adding incoming and subtracting outgoing tokens. In this video, we'll figure out how to rebuild Chainlink balances from transfers, and along the way, we'll fix common Dune mistakes like data types, precision, and typecasting. To start, we need the Chainlink token contract address, which we can get from the token table or Etherscan. We start with incoming transfers. Tokens go into an address. We take all transfer events for the Chainlink token. We focus on the to field, which is the recipient address. For the amount column, we assign a positive value, since the token is flowing into the wallet. One thing to be careful with in Dune is data types. Nothing is inferred automatically. Everything has to be explicit, otherwise your calculations can break. For example, this won't work, because block time is a timestamp and your date is just a string. So we need to be explicit. Same idea can also be written with cast. Now we apply the same principle to token values. Raw ERC20 transfers come as large integers, so we cast them before using them. We convert raw on-chain numbers into a format that SQL can safely calculate with. 38 is basically the max precision Dune gives us here, and 0 means no decimals. Without this step, results can be incorrect when we start aggregating balances. Now we do the opposite. These are tokens that leave the address, so we represent them as negative values. We multiply the value by -1 and cast it as decimal. Now we use union all to combine both flows, incoming and outgoing. This gives us the full movement of tokens. To keep things clean, we wrap both flows into a CTE called transfer detail. Next, we aggregate balances per address and store the result in a CTE called address balance. At this point, the balances are still in raw units, so the numbers look huge. To fix that, we convert them using 1E18. There is just one nuance. After converting values using 1E18, very small balances can turn into tiny decimals and effectively disappear, and that can slightly affect the holder count. We run the final query and get two key outputs: holder count, number of addresses with a positive balance, supply amount, total circulating supply on chain. Then we compared with Etherscan. The total supply matches almost perfectly, which is expected, but the holder count shows a small difference. This is because after converting raw values using 1E18, very small balances can become negligible and effectively disappear from the holder calculation. Now we understand how balances are reconstructed on-chain, but balances alone don't tell the full story. In the next video we'll go deeper and look at who actually controls the supply. See you guys.